Well, it is 12:30. I don't want to penalize you for being on time. So thanks for coming. Thanks for participating online. I'm Dennis Buckmaster, a professor in ag and biological engineering, also a Dean's Fellow for Digital Ag. This is part of the Data-Driven Agriculture webinar series. It's kind of a combination of digital ag, plant sciences initiative here at Purdue, and the Integrated Digital Forestry Initiative. And so today's topic, you can see there on the slide. We're very fortunate to have our presenter today, who is Dr. Beth Hall. I'll give just a brief introduction. She is the director of the Indiana State Climate Office. She was previously the state climatologist in New Hampshire. She's also the director of the Midwest Regional Climate Center, which actually covers 9 states, and probably we'll see some map of that in her deck today. Her degrees are in atmospheric physics and science. She has a very storied career in climate and weather. I think you're just going to be inundated with the number of resources that she's going to point us to today. So whether you're here in person or online, probably going to want to keep your eye and ear on what she's saying, but probably also have a browser going to launch this site and the next site and the next site. And if you can't keep up, this is being recorded, and we'll get the link out, and you can always catch up on the recording as well. Beth does contribute to the Vegetable Work Crops online hotline pretty regularly, probably lots of other places that I'm not aware of as well. So she really does live out this land grant mission of outreach on behalf of Purdue and all of her employers. My last comment is she is I have to say it out loud, Indiana University graduate, and followed that with degrees from the University of Nevada. So I can't give her a hard time about the color of her blazer. You'll see it in just a moment. It's not for her institution, it's for Christmas. So I'll just give her credit for that. So Beth, thanks very much for sharing today. Really look forward to what you have to show us.
Thank you, Dennis. Yeah, we could call this Christmas red, or we could call it crimson if you want. But I understand that's a dangerous thing to say here. I really appreciate being here today. Hopefully, I will be able to convey through this presentation how passionate I am about climate and weather data and the services that we provide. I know that the title of this presentation is Weather and Climate Data for Non-Meteorologists, but a lot of this is going to be tying into what does the Midwestern Regional Climate Center do? What is a state climatologist? What sort of data is out there? What are the nuances of the different data sets? Something that I tried. It's like it all goes up. Okay. So I had some previous slides, but I know this is going to be a fairly long talk. Those previous slides were highlighting all the different climate organizations that are out there. And when people hear that I am a climate scientist, I think nowadays, because climate change is such a big issue, they ask, well, what's going on with climate change and what research are you doing? And they want me to give presentations about climate change. But really, I would describe myself as more in the realm of climate data services or applied climatology. And so for the rest of this talk, it's really about what are climate data services? What sort of climate data is out there and what provides value to my job? So I do have a couple quotes up here that was taken that are from organizations that have defined what climate services is, but I realize in a presentation nobody wants to really read. So that's why I just broke it down to that bottom line. That climate services or climate data services is there's lots of data out there. In this particular case, we're going to be talking about observational data of the atmosphere and in some cases soil, very at shallow depths, at root depths. But most of the time, people don't want raw numbers. Your everyday person does not want to see a whole spreadsheet of numbers. They want information. And so people who are in the field of climate services are working to try and translate all those numbers into something that the audience, the stakeholders, this could be researchers, it could be lawyers, it could be any range of people, into the information so that they can make decisions. And this then ties back to when I said that I also consider myself to be an applied climatologist, because an applied climatologist just takes the data, the weather data, and applies it to anything that's really not climate focused. So where do we get the data? In the US, there's 3 different tiers of where data is being collected and where it's being disseminated and how people talk about it. The first and probably obvious one is at the federal level. So your tax dollars, thank you, by the way, help fund a variety of weather collection networks around the US. I will show you 3 of them shortly. I think in terms of meteorology, this is all being done through the Department of Commerce at the NOAA Oceanic and Atmospheric Administration. In Asheville, North Carolina, we have our big national centers for environmental information. And actually, it's in that group that funds the regional climate centers that I'll talk about later. And then you've probably heard about the National Weather Service. So those are the 2 big entities that are collecting the data. And then the regional climate centers ensure that that data is freely available to you or to any taxpayer. Then there's data available at the regional level. And so this is where the Midwestern Regional Climate Center would come in. And really, the regional climate centers are the only entity that I would put under that category of climate data and services, because they are the stewards, if you think, of federal data that's being collected. And then they also work very closely with the state climatologists, but they tend to focus on the issues of that region. So if it was, say, the Southeast Regional Climate Center, so we're talking Florida and so forth, their big issues might be coastal. It might be tropical storms. And so when they're collecting meteorological data and then transforming that into information for their region, it's going to be focused on coastal issues. The West might be more interested in wildfire issues or drought issues. In the Midwest, you're going to probably think agriculture is going to be the big emphasis. And then the state level. And so almost every state has a state climatologist, though I can tell you, I believe we have 52 state climatologists out there, even though not every state has one, because Puerto Rico and Guam have one. And I think there's another, maybe some islands have some. So I'm going to step through now these different levels of what essentially data do they provide, if any, where you can find the data, and maybe the nuances of those different data sets. So starting off with federal data, probably the biggest network of observational data that has been around for the longest is under the National Weather Service's Cooperative Observer Program. And this program really became officially organized and collecting the data across the US since 1895. So we can do the math of how far back the data record goes for many of these sites. Way back, they were, now they're volunteer observers, but I think many, many years ago, many decades ago, they might have gotten a token amount of money from the government thanking them for the effort. But you can see off to the left that these observations, because they're done by actual volunteers, humans like you and me, it's once a day. Most all of these observations are done around 8 o'clock in the morning. And I'll go into why that's fairly important soon. And what they're observing at the weather station that has been provided to them by the National Weather Service, so they don't have to purchase their own equipment, is the maximum and minimum temperature over the last 24 hours and precipitation. But that precipitation is going to be liquid, so rainfall, snowfall, and then snow depth. So I want to go back to the fact that these observations are done in the morning. First of all, what person are you going to get up at midnight to try and do these? So we have a midnight to midnight record. So if we had a huge snow event yesterday, Wednesday, and we want to see through the historical record, oh, I remember when that happened in it was the end of November or early December, you would actually see that amount as a December 1st value, even though all the snow fell on November 30th, because the observation was taken and recorded then. So there's some nuances with daily data, because you aren't going to know anything about, say, the intensity of a rainfall event, you assume the maximum temperature happened in the middle of the daylight hours, but not necessarily. And I want to highlight here that you'll see 2 colors. You'll see blue dots and gray dots. And down in the bottom left, I define here that the blue dots, and I zoomed in on Indiana here, are those cooperative stations, we call them co-op, stations are still active. So if you're trying to figure out where can you get data just from even yesterday, and it came in because of computers now, they report every morning through a system, so we can be pulling in this data 7, 8, 9 o'clock of what they saw in the last 24 hours. All the gray dots are those that we have data for, but they're no longer active. Most of the time, these observers are farmers. They were the ones that were getting up early in the morning. They had the most vested interest in what the weather was happening at their locations. But you can see, in a sense, the sadness of we are losing that dense population of farmers. And so we're losing a lot of these observations. Our closest cooperative site here to Purdue is at the Acre facility, if you're familiar with that. That data record goes back to 1901, which is phenomenal. It wasn't even part of Purdue back in 1901, which means that whoever had that land prior to it being gifted to Purdue or Purdue purchasing it, I don't know the story there, they were taking observations through this network. So it is a great resource of information if you do want to look back at that. So not every station goes back to 1901. Some go back to 1895. Some go back to 1860s even. But the official coordination, we say, starts in 1895. Then federal data, we have weather stations at all the airports, and you can probably understand why. You have to have the safety for the planes to take off and land. These aren't just our major airports. Usually any even rural airport needs to have some sort of weather data collection take place. You'll see here, though, that it's hourly because the planes really need to know what's going on at all times. That data set, even though airplanes existed prior, there can be some sporadic data that starts prior to 1948. I would say, in general, a lot of these airport networks, weather stations, start in 1948. The other caveat, though, with this is it was actually manual observations. To date me for a while I was a student at Indiana University, I did a shadow internship at the Indianapolis National Weather Service. And one day I shadowed the person who was doing the hourly observations for the airport. And now it's all automated. So around the mid-1990s, they decided, well, it was cheaper to do an automated station than to pay somebody 24 hours a day. Obviously, they did shift work. To take all of these observations. So you might see some almost step shifts in the data for when we went from manual to automated to then a different automated system. In addition to this being a nice data set because it's hourly, I've highlighted the additional variables that you can get from these sites. So from an agricultural perspective, isn't it nice now to have humidity and to have winds, particularly if you're thinking about spraying crops? Cloud height and pressure, maybe not so much, but every application is different. You can also see here, the green dots are where it's still active. We're still pulling in data for those stations. And if you look really hard, you'll find a gray dot every once in a while where they deactivated that station. So we do have quite a few of those locations here in Indiana, but it's not as dense as that cooperative network. It's the trade-off, right? You get more variables, 24 a day as opposed to 1 a day, but it's not everywhere. Also, for agricultural purposes, some might argue, wait, but the conditions at an airport aren't really the conditions at my field. So, how much give and take do you want? One thing that you might notice is not here that is very important to particularly crop growers is there's nothing about solar radiation. And if you're interested in evapotranspiration, solar radiation is a very important variable. So there is a federal network of stations that does observe solar radiation and even soil moisture and soil temperature at various depths. But you'll see in Indiana, there's just one location for this. So I started here in early 2019, and I can't tell you how many times I get questions from people saying, do you have a climatology of sunshine days or, solar radiation throughout the growing season? And it's like, I don't. And this is one of the problems. I mean, I'm happy to give you the data for this, but is that representative across the whole state? So it is nice that we do have additional variables. I've crossed off, though, that these climate reference network stations do not do winds or pressure or cloud height. Again, pressure, cloud height may not be a big deal, but winds might be nice for some of this because the winds, I believe, do play a role in evapotranspiration. So how are you going to compute some of these derived variables if you're not getting all the parameters? Also, this particular network is relatively young. They really started installing it in the late 1990s. So unlike the previous two federal networks that go back, have a great period of record, this one is awesome in what it's trying to do, and we're building up obviously a long period of record, but we have a ways to go. So you might ask yourself, well, that's cute, but where do I get this data? All of it is free. You can go to any regional climate center. You don't have to go to the Midwestern Regional Climate Center if you're trying to pull any of this data around the Indiana area, though I personally am fond of the MRCC as director. The URL is at the top, so it's very easy to remember because we're right here at Purdue University. And in terms of where you actually get the data, we have a full online data portal here. So when you log into this site, you will just click on Climate. It even says down at the bottom, online data portal. You do have to register an account, but it is free. As soon as you type in, hit, then you can immediately log in. You don't have to wait for anybody. And that's mostly so we can just track what are people accessing, because we are getting federal tax dollars. We need to report back on the usage of that. So that you can get the daily data there, you can get hourly data. There is some state data there, but there's also a wide variety of mapping tools on there, graphing tools, derived, like growing degree day, heat index. There's wind roses on this climate data portal. So I know some of you might just want the data, but if some of you are also thinking, I don't know, I just kind of want to draw a map of this, or see the climatology, or see the departure from normal. All of that you can customize and create through that climate portal. There, from the federal government, in addition to providing those weather data collection systems, there are some great online, what I would call climate data services that takes the data and converts it into more usable information. And one of my favorite one is NOAA's Climate at a Glance. I don't have a URL here because honestly, it's easier to just Google NOAA's Climate at a Glance and you'll find it. But you can see from the top row, and this is just a screenshot of a web page, you can go at various different spatial scales, global, national. I have highlighted here divisional. So a lot of states have around 9 climate divisions. So if you think about north, south, east, west, northeast, southwest, and then the one in the center. So we kind of capture a good geographic distribution of the state. You can even go down to county and city. You see the various parameters here that you can explore. So I don't show you the parameters, but the different fields you can choose from. So you can do the full contiguous United States. You can just do Indiana. You can do what year you're looking at. Time scale, I've done this a couple times when people will say, so how was our last summer? Or how is our last growing season? And so I might think, well, if they're defining the growing season at the end of September, maybe it started in April. Of course, I have to count on my fingers. How many months is that? So on time scale, for month, I might put September, and time scale, I might put 6 months. And then I can get a nice captured picture of what was happening this year. So this is just one example of the case I put in on the previous thing was February. I think it was average daily temperature. You can get a quick look at this. You can see the tabs at the top. This is just highlighting, color shading by climate division, the values, but you can also see how that ranks over the full climate record that goes back to 1895. You can look at the anomaly of how that compares to the 30-year normal, and then the mean, and then down at the bottom, it can highlight things. Now, at the very top left of this screenshot, you see January. I think I actually pulled this screenshot in February, but if I were to pull it today, you would be able to tab forward up to the current month, tab backwards. So it's a nice way to kind of go month by month, or 3-month chunks, 3-month chunks, etc. And then finally, if you just want the data that was there, you just have to scroll down that page a little bit more. So maybe you're curious about, that's cute in a map, but I really want to work with the raw data here. So you can see how we have summary data, and the output for that is Common Limited, JSON, XML, etc. Other things that, and like I said, I'm not going to go through all of these with Climate at a Glance, but Timeseries, I'll use this a lot in my presentations, and I've seen other extension specialists put this in their presentations. Maybe you want to show how things progress precipitation-wise, temperature-wise, drought-wise, a whole bunch of different parameters. Again, you can pick your start year, end year, but one of the things I really like about the time series plot is the options box to the right. You can pick what your display period is. Maybe some people want to see a time period of just the last 10 compared to the last 10 years. or maybe they want to compare it to the 20th century. So you can actually determine what is that base period that you want that, say, solid black line to display on your time series to show how things are comparing. You can display a trend line to it to show are things increasing or decreasing, and then a smooth line. So that's just where you would go for the time series. And then here's an example based on the parameters from my previous screen. So you can see that I picked the 20th century baseline. That's the black flat line. I have a trend line in there, and then I did apply a binomial filter to try and smooth out some of the noise. And again, you can pull the raw data values from a product like this. That Climate at a Glance has a whole bunch of other tools in there. I don't really have the time to go into all of them. If anything, you can skim down this list and then maybe just spend a lunch break, looking at the various climate tools there, because I bet there's something in there that you could use in your next presentation. Like I said, there is data, so I don't know if it's the best place to try and pull raw data for research, but if you're trying to communicate the story, tell the story of what's going on relative to your work, there's a lot of great material here. Moving on to the Now Data tool that's offered through the National Weather Service. Now, unfortunately, this one is not an easy thing to Google, because when I Googled National Weather Service Now Data, I got an informational page. But down at the very bottom of the slide, I put in what did work. So when I Googled Now Data Indianapolis, or you pick your favorite way, there's a weather station, an office, or area. And then once I go to that page that came up relatively first, if not first, I then found a link that said current and past weather. And that took me to this Now Data page. From here, you can do a variety of things, from mapping to time series for a bunch of cities. You see, you can go through the list of cities on the left. You have various options. One thing that I want to call out, though, for you guys is they have this nice feature of first and last dates. So for agricultural purposes, you might be curious of, so historically speaking, what was the last date when the minimum temperature, in the spring, when the minimum temperature hit 28 degrees Fahrenheit? And then what were the historical dates in the fall when the minimum temperature first hit it? And so you can put in those parameters of whatever you want. It can be precipitation as well. And then you have this nice list of data. It looks like you can totally print this out. I would guess you could click and drag over the data file and see it. But if you're also just trying to do a quick and dirty examination of when this was, you can run this tool, and then it's somewhat cut off at the bottom, so maybe our virtual viewers can see it. There is summary statistics there too. So after it presents the whole list of numbers, it will say what was the very earliest, what was the very latest, what was the average date of when that occurred. Here's just an example of some of the graphing that you can do through Now Data. This is precipitation over a period of time. Okay, moving on to regional climate services. So I've mentioned a couple times that we have the regional climate centers, and I'm so excited that the Midwestern Regional Climate Center is now located at Purdue University. We just won the 5-year contract from University of Illinois about 2 years ago. So it had been at University of Illinois since the beginning of regional climate centers, which was back in the early 1980s. So that wasn't any small feat there to do that. But you can see where the 6 of them are located. Again, all of us have access to all national data. So let's say you're doing a project with wine growers in the Pacific Northwest and you need data. You don't have to then try and figure out where to find that from the Western Regional Climate Center site. You can still use the MRCC's data. So the general mission of the regional climate centers, certainly to provide to the public the high quality data, but really for the region, even though we have national data, we're always thinking about what is most important for the Midwest. Like we had some major snow events come through in the northern part of our region, and maybe that's something that's important. We have been tempting drought, it seems, for the last 8 months, and so maybe that's an important thing, and then obviously agriculture. We, as regional climate centers, all 6 of us, we continuously monitor and assess what is happening in our region, and we write at least monthly reports. The MRCC writes weekly reports. So we have weekly write-ups of what the state of the climate was across our 9-state region. We do focus on region-specific needs. We certainly can go for other grants, and so we even have several other grants that come along with it, and there's sponsors that really love to give the grants to the MRCCs because they know we already have the computers, we already have the personnel that know how to work with the data. So there's a lot of opportunity to do the applied research, and then we try to work with key stakeholders to identify what their needs are. Because I really try to emphasize, we're not just a climate data library, we're trying to, again, translate that data into information so they can make better decisions. So while we have the data, that's sort of the background of isn't that nice to us? It's more of, but what question are you asking, and how can we develop a tool, provide a tool for you online that actually makes that data more usable for you than just the raw numbers. I've already gone over Climates. That's that online data portal. So I won't go over that again, but I do want to highlight another major section of our website, and it's called the Midwest Climate Watch. Here you won't necessarily find raw data, but you will find a lot of monitoring information, a lot of the that translation, the kind of the cool maps and things that will help guide you of what is going on in our region. So when you go to just the, so you'll see that there's 3 tabs in this case, and I hate to say this, but we're revamping our whole website. So by early next year, this will be slightly different, but hopefully we're keeping the Midwest Climate Watch name and concept going. But under maps and images, that far left tab, that's where you can see real-time monitoring of our daily stations. So a lot of this is coming from that National Weather Service Cooperative Network I first told you about. So if you remember from that, you could get maximum temperature, you could get the precipitation, snowfall data. We even, because you can take that information, we have freeze maps. At certain times of the year, the snow maps will change and become more useful. Here's an example. If you click on one of those thumbnails, what you see. So this would just be one day, but you can see up at the top above the map, you have a bunch of hyperlinks, -2 days, -3 days. So you don't even have to click on that. You can just mouse over it and the map will quickly change, which is a nice way to just kind of see what happened the last 7 days, to just mouse over it and see when was the big rain events and where. We have a suite of hourly maps. So if you remember from the hourly data, that's where you can get humidity and wind. So we try to tailor some tools that benefit that. For example, here's a map showing what was the minimum wind chill that occurred on a particular day. And again, the user can map over to see, so has it been this cold for like the last 4 days, and how cold has it gotten? So a lot of that sort of interactivity. And then just a whole variety of thumbnails. I know it looks like just a bunch of box of colors from where you're at, but you can even see at the bottom that there's even pull down menus here where you can choose a different month if you want. You can choose the different parameter, because in this case, it's looking at last 7, last 30, month to date, and so forth. So this is another case of when you have a light lunch and you just want to, explore around the data page, I would encourage you to look at this and just see all the different products just under the maps section. And then we also have very high resolution precipitation data. I know precipitation is pretty critical for what people are looking at. At the moment, I think we're displaying daily, but I believe they do have some sub-daily. It might be 6 hourly though, so not hourly. The nice thing with this multi-sensor precipitation data set is it's an integration of what the Doppler radars are observing with the ground truth. And so it's helping to fill in the spatial gaps where there aren't ground observations, but is still showing very good detail. So you can even see in the northeastern part of Indiana, how there's that orange kind of fingers coming out. If there were only 4 stations there, you wouldn't see that sort of detail. So when people contact either the State Climate Office or the MRCC for precipitation data, oftentimes we will remind their mention of this. It's like, well, how important is this? Because just station data may not give you the full picture if you're looking at more of a spatial scale. If they're just looking at what fell on their farm or like an acre, one of our pack sites, and I'm sure that that weather station would be fine. We also have a section on more specialized topics. So there's agriculture, drought, you see some of the other ones, but we knew that there were so many climate-focused tools that were more catered towards a certain field of emphasis that we wanted to segregate those out. So those in the agricultural community doesn't have to try and figure this out from just the previous maps. So here's a screenshot of when a user were to go to our agricultural special topics page. the variety of tools, and it kind of accordions out. So a lot of these are closed, but you can see the ones that are open here, the Useful to Usable project that was hosted or led by Purdue University several years ago. It was multi-year, multi-university, and I think I'll show an example of one of those tools soon. We also show soil temperature maps because that's going to be important for the date of planting and perhaps even harvesting or even applying chemical nutrients. But you can look at even the other options, chilling hours. That's very important for those who have perennial fruits. Freeze maps. Some states offer pest and disease management. So this is, I hate to use the phrase one-stop shopping because I feel like that's been so overused, but we've tried to make it so they can just go to one place if they're looking for an ag-focused climate tool. This is just an example of that useful to usable. One of the tools is called the growing degree date, corn growing degree date tool, and that's what this is showing. And this is probably the most popular tool that was developed out of that useful to usable or U2U multi-year project. But what's nice about it is you can see at the very top of the screen all of the variables, the variety of customization that a user can do. So if they are planting corn, they can put in, well, when did they plant the corn? How many days does that seed company say to maturity? What growing degree day units until we hit the soaking level? And then once they put in all of the different parameters, you see a time series, which is that curve down at the bottom, that shows essentially when we anticipate, the actual date we anticipate hitting some of these critical stages of corn development. And then even those blue bars, the little like blue histogram, if you will, on the bottom right, that is a historical summary of when that particular freeze temperature was first dealt with. And so the parameter that was selected on the top left is a freeze temperature of 28. So a grower can look at this and almost gauge, am I going to make it to harvest before the first hard freeze comes? And so they can play around with different dates. And I know last couple of years, this last year, but particularly in 2019, the spring planting season was remarkably wet. They couldn't get out in the field. And there's a lot of concern of, okay, if we can't get in the field even until late June, are we going to make this crop viable? And so this tool was a fairly popular tool for them to try and make that decision. This is a wonderful example of climate services, right? Because we have the data all in the back end because they don't want to see the numbers. They need information so they can make better decisions. This is just a screenshot of the special topics drought page, just to give you another flavor of what that looks like. I don't know how many of you are interested in drought or water resource issues, but there's certainly evapotranspiration and water balance maps. That's the third row down. Various drought indices, soil temperature. We'll try and add some soil moisture there once the National Soil Moisture Program gets further along. So shifting on, I feel like I have about 12 minutes left if I'm looking at that right, on to state services. So like I said before, 49 of our states has a state climatologist. If you look really hard, Massachusetts is one that we just have had trouble trying to work with those universities and even state government to have one. The different shading here is how many of these are recognized by the national organization, the American Association of State Climatologists. And to be recognized by that organization, you have to meet certain criteria. You just can't say, I'm a state climatologist. Maybe the light gray states that is what they're doing, or they didn't fill out their annual report. So I want to go through a lot because a lot of people are confused about, so what is a state climatologist? What does a state climate office do? What do I do as a state climatologist? And there's no clear-cut answer because there's no continuity between state climate offices. They're all state funded in theory somehow. Some of them are funded though through the university, such as Indiana. So Purdue funds my position. We have Ohio, Colorado, but there are plenty that are actually funded through their state government. Iowa is an example, Minnesota. For many years, Illinois was until their water survey became part of the University of Illinois. Variable funding. So some of them is just who drew the short straw in their atmospheric science department and said, you know, you haven't been doing much lately, so you're going to be the state climatologist, and this is going to fulfill part of your service requirement as a faculty member. And you can imagine how tough that would be to even serve the state if that's what you're asked to do with no staff. When I was a state climatologist at New Hampshire, I was pretty much told that because I was faculty there. And they said, but you know what, we'll give you a $3,000 stipend And I'm like that's gonna help serve the state for 12 months. And then others, the very fortunate one, and I'm very grateful to say that Purdue is one of them, provides a full benefit of salaries. In my case, that 80% is funded through Purdue, and some of them have a very generous operating budget and so forth. And so Purdue, I'm just so grateful that falls in that category. And it was one of the draws of why I went for the position. So I was like, yeah, you're not just making us do extra work, you're actually standing behind it with some money. Variable staffing, a lot of them, I would say majority of our state climatologists is just one person. I was trying to think about the Indiana State Climate Office, and because I'm only 80% and I don't technically have any staff, our office isn't even one FTE. So there are some that are less than one FTE, but there are some amazing state climatologists that are very well staffed, and Colorado and North Carolina are the two that came to mind. And you can see the difference. I mean, everyone in the state knows they exist. They can do so much for the state, and those that you can see the combination of worst case scenarios, how it can really impact things. Various staffing roles. So I actually wear a couple hats. I have an extension appointment. I'm not faculty here, but that extension appointment means that really my focus can be targeted to serving the state. That is a wonderful thing to have as a state climatologist. But some of them, they're full-time faculty. And so the university, the state doesn't really care if they talk to another human being outside of campus. That's not their job. And then the state positions are quite variable there. But it goes on. Some of them, really all, should focus on whatever the big priorities are in their state. So for Indiana, you can imagine agriculture is going to be that. Whether it's row crops, specialty crops, livestock, you name it. To me, that is where I need to spend most of my focus. And when Dennis introduced me, he mentioned that I do write regular articles for the vegetable crop hotline, for pest and crops, and for fancy fruits. Also, so we could have drought, all these other issues in other states that's important. I've highlighted this one though, because to me, this is what really makes a state climatologist, is they're more about outreach than actually being data stewards. So if I wear both hats, as state climatologist and also director of the MRCC, when I'm director of the MRCC, I'm focused on data, tool development, online resources. When I'm wearing my state climatologist hat, I'm focused on how am I communicating to the people of the state? How am I making them safer? How am I making them more profitable? How am I making them more productive from a climate sense? So you can see that it's going to be a lot of articles, presentations, and interviews. There are a bit more climate change linkages with state climate offices and certainly the regional climate centers. And then I would say probably at least 2/3, 3/4 of the state climate offices also have a role in their state programs. And COCOROS is one major program that impacts, I think, every state, and then Mesonets. So that's what I'm going to try and wrap up with quickly. So what is COCOROS? COCOROS is another volunteer program. It stands for Community Collaborative Rain, Hail, and Snow Network. And essentially, it's asking complete volunteers, like all of you in the room, all of you online, to say, if you are a weather enthusiast and you're willing to take precipitation measurements on a fairly regular basis in the morning, sometime between 6 a.m. and 10 a.m., there's a lot of flexibility because we understand it's variable or volunteer, then we ask that you use this particular rain gauge, and you can just submit all of it online, and you can see the density of volunteers that we have. I was meeting before this presentation to look it up. In Indiana, we have over 600, I think it's like close to 660 COCOROS volunteers registered. Rarely do we get over 500 reports in a day, but we've gotten close. It's very common to get like 450 to 480 reports a day. So think about that. Just in Indiana alone, we have that many people that are getting up in the morning, looking at their rain gauge, looking at their snowboard, and then reporting it, because this is totally improved precipitation data that we have. This COCOROS program started, I believe, in the very early 2000s, maybe 2000, 2001. It came to Indiana because it wasn't really completely national for a while, but I should have looked this up too. I want to say it came to Indiana around 2006, 2007. So if you're interested in using COCOROS data, Buyer beware, because you don't quite know where they've cited it. There's a lot of training that we provide online, and as state coordinator, that's one of the things I do is I send out a monthly newsletter trying to remind them of tidbits of, hey, it's about to snow, take out your inner funnel. This is how you do certain things. Please don't put your gauge right under a tree. So, but you can almost look through the data set, and I think it's a reasonable data set to use for precipitation. Then we have Mesonets. That's my final topic. So Mesonets is essentially a conglomeration of two words, a mesoscale network, but in this case, we're talking about a mesoscale network of weather stations. There are a lot of states that host Mesonets around the U.S. Again, I've lost track, but I would say maybe 30, 35 of our states have a state Mesonet. I believe all of them are run and operated out of a university system. Because they typically get started from a research grant or a research need. Somebody sits there saying, I want to study plant growth here. I want to study that. Oh, but we need weather data, so I need to buy a weather station. And next thing you know, like, oh, can you put a station here and there? And that's really how Purdue's Mesonet started. On this map, the gold circles, and if you look closely, you'll find two gold triangles, because those are two sites we hope to install in the spring. That's where the Purdue Mesonet stations are at. So we have a weather station at each of the Purdue Ag Centers across the state at Acre. And then we added 4 more, I think, just over the last, say, 12 months. And then we have 2 more. My ideal dream is we're going to have a station in every county. I don't know if we'll get there by the time I retire, but that would be great. The blue dots represent the other Mesonet in Indiana, and that's operated, it's the Indiana Water Balance Network, and it's from Indiana University, particularly through the Indiana Geological and Water Survey. Why would you care about this data? Well, this now is research grade. We care about it because we're doing research off of it. We can't just ask volunteers to do it, so we constantly are trying to monitor the quality of the data, quality assurance of it. But even more importantly, look at the parameters that we have there. Remember early on, I was saying, well, this is a great network, but it only has temperature and precip. And then you have this network, which doesn't have sunshine. At the Mesonet sites, and this is common through most of the Mesonets across the US, we have soil temperature and moisture, which is becoming more and more important. We're now monitoring low-level inversions at all of our sites, and that's critical because you should not be spraying volatile chemicals when there is an inversion present. Just trust me on what that means. It's something important for the chemical folks. But we have solar radiation that we can do evapotranspiration derivations, wind speed direction, and relative humidity. So the very cool thing, and we even have sub-hourly, it's at 30-minute intervals. So if you're looking at very more dense, if you will, temporally, we have that than pretty much any other network out there. If you're looking for high quality data, the Mesonets are the way to go. If you're even doing stuff across states, reach out to me because a lot of our states have phenomenal networks. Michigan, Kentucky, and Illinois actually have all 3 of them older, and I think just more breadth of their networks. My goal is to try and catch up to them and then get to every county, if you will. If you first Google Purdue Mesonet Data Hub, if you're like, so where do I get the data? Just Google Purdue Mesonet Data Hub, and it should take you to a page much like this. This shows you the locations of all of our Purdue weather stations that we currently have. If it doesn't have a label next to the dot, it's just because the text would have overlapped, and so there's a default that says don't do that. In the top right, you can see all the variables, so it's a pull-down list of all the variables you can choose from. I go through all that on my daily QA/QC because if there's something off, that color is going to stand out compared to all the surrounding colors in the color scheme. If you click on a station, it will take you to, I think, the most recent 30 days or however many hours. And there are scroll bars, vertical scroll bar on the far right, so you can scroll down that list. And then on the bottom, you can scroll to the right and left. But you can see in the options on the right, maybe you don't actually care about all the variables. Maybe you're just interested in a few. You could then check off or check on which variables you actually want. You can choose the start date and the end date. So maybe you want the full period of record, or maybe you just want this last summer. But something else that was a feature that was added is for which months, because we found a lot of people just care about the 6-month growing season. They don't really need all the data. And so if you do that, then you can see there's a download option there. So once you kind of get your table set up with the parameters you want, you can download it. And I believe we offer the common and limited and an Excel spreadsheet. There's also, you can go to the graphs and see time series. Again, if I were to scroll further up, you can control the start and end date. I think this defaults to 30 days. And I've just used 2 example time series graphs just to illustrate some cool things that we have with our Mesonets. The top one is that low level inversion. Essentially, the orange yellow lines are the temperature values, but the bars, the vertical bars, show how strong the inversion was. And the general rule of thumb is if it's a very strong inversion, don't spray, because then it can cause off-target drift and actually be very damaging to another crop. So this is a cool way to see, well, how often do we have inversions at a site? The time series down below is showing the 4 depths of soil moisture that we're observing, and you can see how it gradually dries out at the depths over time, and then we get a major rainfall event, so then it spikes up, and then it starts to dry off, and so forth. So to wrap up, climate services, I really want to bring that home, that it's a pretty important part of our field, because we need the data, but we also need somebody to translate the data. A whole bunch of lists here in terms of what is it that we do. We do the monitoring, we do the research, time series, and the different applications of that data that it can go to. But for the sake of time, I want to wrap up right here. Thank you for your attention during all of this. I have my email up here and then the URLs for the 2 websites, but you can see even the State Climate Office website. I would never remember. I have to look up every time. So if you just Google Indiana State Climate Office, you'll get to us. Thank you.
Thanks, Beth. That's a tremendous amount of information. One of the things I learned today is what the state climatologist does. You're not in charge of the weather, so I can't complain to you.
Sorry, yeah.
And you're less than 1 person, so very insightful. Are there any questions from those that are here? Go ahead.
Actually, I do. So
And if you're online and you have a question, maybe pose it in chat, or we can ask you to unmute shortly.
So first of all, another IU grad.
Awesome.
We just don't fly the flight, right? No, so actually, because this is, I think the weather forecasting seems to be getting worse the last few years instead of better. So while you were talking, I was bouncing around in my different apps, and that's my question. So you know weather is coming, or even if I look at today, I was looking at 3 different apps. Mm-hmm. One says it's 30 degrees, and 2 say it's 27. But then the forecast, one forecast is 36, one is 37, and one is 38. Sometimes you get snow, and I know it's different weather models, right? Mm-hmm. You know, there's enough information, but I guess where's the accuracy? And one of those is actually NOAA, right? So
sure, yeah.
Where is the most accurate that we can rely on, whether it's for work or also just personal use? Do I need to repeat the question?
We picked it up, okay.
Okay. So yeah, lots of different in fact, it's pretty common in early level weather and climate courses in college to have them track those 4 or 3 or 4 websites and see, so which one actually came close to reality. That answer, because I would do that every year when I would teach, it was a different app every time. And sometimes one app will do better, say in the Pacific Northwest, one will do better in the Midwest. I don't remember the answer. It could be time of year as well that has an influence. With all of those, they do employ a large number of people. So they should all be looking at similar models, which is why they're close. Some of them might be putting more emphasis on a model, but then you have that human influence where they might say, you know, this model always messes up when it comes to snowfall, but this one seems to do better. So I'm going to hedge my bets more towards that way. And I think because they're competing companies, with the exception of the National Weather Service, they are more incentivized to be accurate or to provide a product that is friendly to the public because they're trying to get support, ad support. The National Weather Service isn't all about money because it's taxpayer funded, but they're focused on just the safety of, are we delivering information to get people safe and protection of life and property. So a lot of times, I don't know. I mean, I think they're very good. I go to the Weather Service first, just because I know that they are highly trained and used to it. But I know that it's all meteorologists that are employed at these other companies too.
It's when you're out walking and they put the brine down, and you looked at the weather app 20 minutes before. There's no snow in the forecast, or even rain. And they're putting brine down. So I was just okay. Thank you.
Yeah, that could be a whole other conversation.
Yeah.
And did you have a second question?
No, that was
okay.
Any other questions here?
Yes,
go
I
ahead.
have. So how do we know, how we can get like the coordinates of where these weather stations are located? Like, for example, for the PPAC and Acre.
Oh, yeah.
Yeah, the other ones.
I believe, but if not, I will get it added, that once you click on a station, maybe up at the top or somewhere in the tables or something, it gives the coordinates.
Okay.
I think also if you mouse over the station, it might provide the coordinates, but I'll try and if it's not there, I'll try and add it. If it's not there and you need it this afternoon, just drop me an email and we'll get you the coordinates. Because we have the coordinates, it's just, yeah.
So actually, we also have like our own weather station. So I'm from Cruise Lab.
Mhm.
We study diseases, but like we try to predict the diseases, the
Uh-huh.
current diseases in this case. So we have like our own data, and also I wanted like to compare with the weather station that you have. So
Yes.
that would be really useful.
Yes, definitely.
Thank you.
And I know that the WIN network, the Wabash Heartland Innovation Network, has deployed a whole bunch of weather stations. And we communicate regularly, and they've installed one of their stations right next to ours at both Acre and Throckmorton, TPAC. I just haven't had the time to do the analysis to see how well are they comparing to each other. So, but it goes to that, we want the best quality, right? We want the highest reliability. Both of our, WIN wants to have good data, we want to have good data, so we got to do that.
Quality comes in two dimensions. One is the spatial resolution,
Yeah.
which often comes at a cost of, well, not every one of those can be research grade.
Okay.
So do I want lots of data, or do I want a little bit that's really good?
Yeah.
Right?
That's why there's never one answer for anything.
Yeah.
If somebody just wants to know, hey, I want an outdoor wedding in June, when's the best weekend? We can look at
Well,
it.
which year were you going to get married? That's what you want to ask in the host.
Yeah, or 80% of the time it rains on that third weekend.
Are there any questions online?
We do have one from Aaron.
Can you just read it out loud for us?
Yes, what investment would be needed to other research sites, those not a PAC, added to the Purdue Mesonet?
That's a great, I love that question since I want to have a station in every county. So when I purchased the last 4 weather stations of the group we added, it was around $10,000 per station. But that was pre-war in Ukraine, pre-supply issues and so forth. So I would certainly say assume more 11 to 12,000 for that. And when we purchase stations and try and find land hosts for the station, we ask them to be the ones to buy the concrete and dig the hole for the base of the station. And if it's in a very public location, we want them to put up a security fencing as well. So they might have to take on another, say, $1,000 to do that, but we feel like it's part of the buy-in. If they invest on it, then they'll help. But yeah, I would say rule of thumb, 10 to 12,000 for a weather station. And then it's always, I found the hard way, it takes forever to get the contracts, the site host to identify a site host and so forth.
So we're still waiting for another question. We've just got a couple minutes left.
Mhm.
One I have, and now that I know that the state climatology office in Indiana is less than 1, but the Midwest region, I look at the tools that are there, the fabulous websites, APIs, etc. How big is the staff that takes the raw and generates tools? Like these have to be some tremendous coders, data visualization people, etc. And how big is that group?
Yeah, so currently the MRCC, and I would say that we are fully staffed at this point, but I put quotes around that, if you will, 6 people, but there's soft funding that's supporting some of that. I would say that probably translates closer to about 4.5 FTEs. But of those bodies, those warm bodies, half of them are programmers. And then the other half includes me. So you have a director, you have the associate director that's writing the reports, the outreach person that can help when somebody calls in and says, I want data for this location. So, and I would think that's true though, that we're looking at maybe part-time adding on more people, and that will probably be a programmer because we just never have enough programmers.
Yeah.
And when I was at Illinois, I often said it was about 5 FTEs, but spread across about 8 people.
Yeah.
And it can be very tough because a lot of times the federal funding doesn't increase, but the cost of living does and pays do. So the contract from the federal government probably only pays about 3 FTEs of that, 3 to 4 FTEs. Mm-hmm.
Any more questions online? Got time for one more if somebody had one. One thing, thank you so much for presenting. One thing I really gained from this is that the office is not just a library or a depot of data, but it is a service provider, which of course is what the world needs. So we thank you for that. So there is a question.
There is one more follow-up to the previous one. What is different about the $10,000 equipment to collect this data and the new low-cost sensors being developed for ag research?
That's a good question, and I think it's become somewhat of a debatable thing because I think that, so we use Campbell Scientific equipment for our weather stations, and that tends to be the most expensive that's out there. All of the Mesonets, in fact, I don't know of any other state Mesonet. When I say Mesonet, I'm talking about the state run usually through the climate offices. They all use Campbell Scientific as well, and so that's kind of important that we match our sensors so you don't have this mix and match. Davis is the next one that's considered high quality but is extraordinarily cheaper, and so that's where I think that's what the wind network is doing. I am not comfortable though saying that my data is better than wind's data because I haven't done the analysis. And maybe I'm the fool for spending as much as I am on Campbell Scientific, but a lot of people have approached us saying, well, I'm willing to spend $3,000 and I can get a Davis station, and why can't you add it to the network? To me, I'm concerned, how much apples and oranges are we looking at there? I really like knowing that all of our sensors are the same model from the same company. But that's not to say that the wind network is bad in any way, or that Davis sensors are bad. And if you're investing and want to go there, I will say that it's more than just the upfront cost. Other state Mesonets have said just the annual sustainability costs for a station runs about $2,000 a station. And what is that paying for? Well, that's paying for a field technician to go out at least 3 times a year to every site to calibrate all the sensors, and any sensor with a moving part, mostly those wind sensors, need to be switched out, need to be replaced annually or recalibrated annually. Precipitation, if it's a tipping gauge, precipitation gauge. So, and then you have the office side of it. You know, who's running the website, who's building the tools, who's creating the data delivery system. And so I think a lot of people forget about that. It's like, well, I'll write you a check for $10,000 and you can buy a weather station. I'm like, okay, but we kind of need the long-term sustainability costs.
Thanks so much.
Thank you.
Again. So we do have a series going in the spring. We haven't fully set the schedule yet, but be alert to your email for the announcement of those. It looks to be an exciting series in the spring as well. So again, thank you, Pat, for covering the climate and data services.
You're very welcome.
Have a great day, everybody.